We live in a world of solidity, a world that feels certain beneath our fingertips. The wood of a table, the chill of metal, the warmth of skin. We tell ourselves that this is matter, and that matter is real. But the truth is far stranger. The universe is not solid. It is not even stable. Everything we see, everything we touch, is built upon particles that refuse to share the same space. Particles that exist only because of their disobedience. They are called fermions, the quiet architects of reality, the builders of every atom, every star, every breath we take. And yet, no one has ever seen one. At the smallest scales of existence, matter dissolves into probability. The electron you imagine orbiting a nucleus is not there. It is a wave of potential, a ghost pattern of where it might be. It has no edges, no surface, no certainty. It exists as a rule, not as a thing, and that rule is simple and absolute. No two fermions can ever occupy the same quantum state. They cannot overlap, they cannot merge. They can only coexist by keeping their distance, an eternal act of refusal that makes existence possible. Without that refusal, the universe would collapse. Every atom would flatten into nothing, every star into silence. The Pauli exclusion principle is not just a law of physics. It is the boundary between something and nothing. It is the first no in the history of creation that we owe our existence to that word. It is strange to think that reality survives through separation, that the cosmos sustains itself by saying stop. And yet this cosmic law is what gives the universe its texture. It is why electrons form shells instead of falling into the nucleus. It is why matter resists compression, why stars are born, why the atoms in your bones will never become the atoms in mine. Every particle of matter in the universe, from the dust of dying stars to the neurons in your mind, follows this same quiet refusal. And yet, this defiance gives birth to everything. Perhaps that is why Enrico Fermi, the man who gave them their name, once said that physics is not about what exists, but about what cannot. So what are fermions really? Are they the ultimate bricks of existence, or are they the shadows of something deeper? Because when you look closer, the illusion begins to unravel. Each fermion, each so-called particle, is not a tiny sphere, but a vibration in a field. An excitation, a flicker, a disturbance in the fabric of reality. They have mass, but they are made of nothing. They are the rules of the game pretending to be players. And that raises a question that scientists, philosophers, and mystics alike have struggled to face. If everything that seems solid is built on things that are not, then what exactly are we standing on? When you press your hand against the table beside you, the resistance you feel is not solidity. It is the Pauli exclusion principle, an invisible quantum protest that refuses two sets of electrons from occupying the same coordinates. What feels like touch is the impossibility of touch. You are not connecting with the world. You are colliding with its boundaries, and still, you exist because of that collision. Every molecule in your body is shaped by this law, from the atoms in your blood to the iron in your heart. Fermions form structure through separation. They define you by what you cannot be. But this is where the mystery deepens, because at the heart of every atom, there is something unexplainable, an electron that should fall into its nucleus, but never does, a neutron that should collapse under gravity, but resists, a rule that no one fully understands, but without which everything ends. Maybe this is not a universe built on matter, but on restraint, a cosmos that endures through the art of saying no. And if that's true, if existence itself depends on separation, then what does that mean for consciousness? For life? For the idea that we are somehow one with the universe? Perhaps we are, and perhaps we aren't. Maybe everything we call connection only exists because of what cannot connect. Maybe reality is not built from unity, but from sacred distance. Fermions do not share, they do not overlap. They define existence by remaining apart. And yet, in their separation, they build everything that ever was. A paradox so perfect it borders on divine. Across the observable universe, from the heart of neutron stars to the space between your fingertips, this law reigns supreme. Every galaxy, every planet, every living thing, all sustained by particles that will not yield. They form the scaffolding of the cosmos not through cooperation, but through limitation. The universe, it seems, is not held together by love or chaos, but by boundaries. And so we return to the question that haunts every physicist. If fermions are real, why can we never find them? Why do they vanish the moment we try to see them? Why do they exist only as probabilities, as patterns in equations, as whispers of an unseen order? It's as though the closer we get to understanding reality, the more it seems to disappear. Maybe fermions are not objects at all. Maybe they are the universe remembering where it cannot go. A kind of cosmic memory, encoded in refusal. If you are enjoying this journey into the unseen, remember that the frontier of reality is not a place you reach, but one you awaken to. So stay with me, because what lies ahead will challenge not only how you see matter, but what you believe is real. Because in the chapters to come, we will descend into the forbidden mathematics of existence, to find out whether the very particles that build you, that built every star that ever burned, are even real, or just the universe pretending to be solid for one brief, beautiful moment in time. At the dawn of the 20th century, physicists believed they had nearly solved the universe. They could map the orbits of planets, predict the motion of atoms, and calculate the dance of light. The cosmos seemed like a perfect clockwork, vast but knowable. Then came the electrons, and everything broke. No one could explain why they arranged themselves in shells around the nucleus, refusing to pile together. They behaved like children who could never sit in the same seat twice. There was order in their defiance, but no known reason why. Until 1925. A young Austrian physicist named Wolfgang Pauli proposed something audacious. He suggested that nature itself forbade two electrons from sharing the same quantum state. It wasn't a force or a field, it was a rule, an invisible line drawn through the heart of creation. It would come to be known as the Pauli exclusion principle, and it would become one of the most powerful laws in the universe. No two identical fermions, electrons, protons, neutrons, can ever occupy the same set of quantum numbers. They must differ by at least one property: spin, momentum, energy, or position. They must by nature remain distinct. And it is from this separation that all structure emerges. It is hard to grasp the magnitude of that rule, because it sounds small, abstract even, but imagine a universe without it. Every electron would collapse into the lowest energy state, atoms would implode, matter would dissolve into a uniform soup of identical particles. The stars would not shine, you would not exist. The universe survives because fermions refuse to share. That single act of disobedience is the foundation of all form. It is the reason atoms have size, the reason chemistry exists, the reason the universe is not a smooth, featureless fog of sameness. In the quantum world, exclusion creates identity. Every particle earns its place in reality by being unable to copy another. It is the most profound expression of individuality the cosmos has ever known. You might think of it as cosmic etiquette. Each electron, each proton, each neutron saying quietly, that space is taken. And in doing so, they define the architecture of existence. In hydrogen, one electron sits close to the nucleus, content in its unique quantum state. In helium, a second joins, but it must differ by spin, like a mirror image. Add more electrons and they begin to layer outward, forming shells, one by one, step by step, until the entire periodic table arises. From gold to oxygen, from carbon to uranium, the variety of the universe flows from one cosmic law of refusal. But this law does not stop at atoms. It echoes across the cosmos. In the dense hearts of white dwarfs and neutron stars, fermions reach their breaking point. Billions of tons compress under gravity, But even as they are crushed, the exclusion principle holds. It resists collapse. That resistance is called degeneracy pressure. It is not born of heat or fusion, but of identity. Matter screaming into the void, "I will not become you." It is the quiet defiance that keeps dead stars from turning into black holes. A final stand of individuality against the weight of infinity. When Pauli first proposed this, he could not have imagined what he had unleashed. A single equation that governs the structure of matter, the behavior of stars, and the pattern of existence itself. It is a rule so absolute that the universe cannot break it, only yield to it. And yet, the principle raises a question as haunting as it is beautiful. If all matter is built on exclusion, then what is inclusion? If creation arises from refusal, what does that say about the nature of the universe itself?
Perhaps existence is not a gathering, but a separation.
Perhaps the cosmos is defined not by what it holds, but by what it withholds. There is something almost philosophical, even moral, about it. A universe that enforces individuality, where sameness is forbidden, and uniqueness is the only path to survival. And yet this same law that keeps us distinct also keeps us together. Without it, there would be no molecules, no matter, no us. Exclusion is the architect of connection. It is strange, isn't it? That everything you've ever loved, every person, every thought, every moment, exists because particles said no. But where does that no come from? What enforces it? Is it a mathematical necessity, or a deeper truth written into the fabric of being? For nearly a century, physicists have obeyed the rule without questioning its origin. It works, it explains, but it does not reveal. What if the exclusion principle is not just a property of matter, but of consciousness itself? What if the universe's refusal to overlap is the very thing that allows awareness to exist? Boundaries creating selfhood, separation creating perception. We think of matter as something external, cold, lifeless, mechanical. But what if, at its core, it behaves as though it knows it must remain distinct? That awareness and matter are not opposites but reflections, both built upon the same principle, identity through difference. In that sense, every electron in your body, every proton in your blood, is a declaration of being. Each one saying, "I am not you, and because I am not you, I exist." The Pauli exclusion principle does not just define atoms, it defines individuality. It defines existence itself. And yet, as we go deeper, the boundaries blur. New research suggests the line between exclusion and inclusion may not be absolute. There are particles that can defy it, hybrid entities that bend the rules, whispering from the frontier of physics that the separation between fermions and their opposites, the bosons, might not be as unbreakable as we thought. In those strange places at the edge of quantum law, we may find the next clue. A new class of being that challenges the very foundation of matter itself. Stay with me, because in the next chapter we will descend into the heart of the paradox, where order and chaos coexist, and where the very fabric of the universe begins to question its own design. In every corner of creation, two invisible tribes rule the universe. One is bound by refusal, the other by union. The first we call fermions, the loners of the cosmos, forever keeping their distance, refusing to share the same state. The second, bosons, the gatherers, the harmonizers, the particles that love to merge, to overlap, to become one. Where fermions define form, bosons define flow. Where fermions make matter, bosons make movement. They are opposites, yet neither can exist without the other. Together they write the code of reality, a duet of isolation and togetherness, of solidity and light. Every electron, every proton, every neutron is a fermion. Every photon, every gluon, every force-carrying particle is a boson. Without fermions, the universe would have no shape. Without bosons, it would have no life. And so the cosmos begins with a contradiction, a balance of refusal and embrace. At the quantum scale, that balance becomes everything. Fermions with their half-integer spins create individuality. Bosons with their integer spins erase it. A fermion says, "I am here and nowhere else." A boson says, "I am everywhere at once." One builds walls, the other dissolves them. This dance defines every atom, every field, every star. It defines you. The photon, a boson, carries light and allows vision. The electron, a fermion, holds space and allows form. Together they create perception, the illusion that we can see and be seen. Without their cooperation, there would be no reality to experience. And yet, they are governed by laws that could not be more different. The universe, it seems, is built not on harmony but on tension, not on simplicity but on contradiction. Perhaps that is why nature never stops oscillating between attraction and repulsion, chaos and order, unity and separation. Perhaps creation itself is an argument between these two tribes. When bosons gather, they form states of pure coherence, like the eerie silence of a Bose-Einstein condensate, where millions of atoms merge into a single quantum identity. Every atom becomes identical, every vibration moves in unison. It is as though individuality itself has been erased, a glimpse of perfect unity. But that perfection comes at a cost. The moment it is disturbed, the system collapses. Reality cannot survive in endless sameness. It requires friction, difference, the defiant heartbeat of fermions. In the depths of space, the same principle applies. Stars exist because fermions refuse compression, electrons pushing back against gravity's endless hunger. That refusal births balance. Balance births light. From that light, life emerges. Order, it seems, is not the absence of chaos. It is chaos tamed by constraint. A constant dialogue between the urge to merge and the need to remain apart. Physicists describe this mathematically: Fermi-Dirac statistics versus Bose-Einstein statistics. But what those equations really describe is an eternal conversation between opposites. One counting individuals, the other counting collectives. One saying, "I am distinct," the other whispering, "We are one." You might think of it as the universe breathing, inhaling unity, exhaling distinction. Every star, every atom, every thought is a breath in that rhythm. And somewhere between the inhale and the exhale, existence happens. But this raises a question that physics, for all its precision, cannot answer. Why should the universe divide itself at all? Why should it split its essence into opposites, particles that refuse and particles that embrace? If everything began as one, what compelled the one to fracture into two? Perhaps the answer lies not in equations, but in experience. Consciousness, too, is born from separation, from the illusion of self and other. We experience unity only after knowing division. We reach for meaning only after being torn from it. Fermions and bosons are not just physical entities, they are metaphors written into the universe, matter and light, boundaries and bridges, self and soul. Their duality mirrors our own, the endless human pull between solitude and connection, between individuality and belonging. We are made of the same laws we wrestle with. Every atom of your body is a temple of fermions, carefully spaced by exclusion. Every thought in your mind is a photon's whisper, bosonic light dancing between those boundaries. You are the argument embodied, structure and energy, chaos and order, matter and mind, and the balance between them is fragile. Push too far towards separation, and the universe freezes into isolation. Push too far toward unity, and it dissolves into sameness. Somewhere in between, in that tension, life emerges. So perhaps the question, are fermions even real, is not about matter at all. Perhaps it is about the meaning of boundaries. Because if everything that exists depends on particles that refuse to share space, then what does it mean to love, to connect, to merge? How much unity can reality endure before it collapses back into nothing? The deeper we study fermions, the more we see that exclusion and inclusion are not opposites. They are partners. Each depends on the other to define itself. And maybe that's the secret of existence, that the universe is not one or many, but both. A field of infinite sameness, discovering itself through difference. It is a paradox that every civilization has tried to name: yin and yang, order and chaos, light and shadow, fermions and bosons, two sides of the same breath. One refusing, the other embracing, one holding, the other releasing. One defining, the other dissolving. Together, they create everything that has ever existed. And yet, this balance is not perfect. There are anomalies. Particles that do not obey the rules, that blur the boundary between the two tribes, as if mocking the simplicity of our categories. In the years ahead, we will meet them, beings of quantum twilight,
that may hold the key to a new form of matter,
and perhaps to a new understanding of reality itself. Because sometimes when the universe cannot decide what it is, it creates something in between. And that in between, that forbidden middle ground, may be where truth resides. At the edge of perception, there is a world beneath the world. A place where solidity dissolves into rhythm, and every particle is a vibration in an invisible song.
This is where the fermions live.
Not as objects, not as tiny marbles spinning through space, but as disturbances in a field. Patterns of presence etched into emptiness. To see them, you must first let go of what you think exists, because at this scale, there is no surface, no color, no light. There is only probability, a shimmering ocean of maybes. Each fermion, electron, quark, or neutrino, is a localized ripple in this sea, and what we call matter is simply the interference of these ripples. A standing wave of persistence in the void. What makes a fermion different from anything else is its spin. Not spin as in motion, but spin as in identity. It is not something that turns it is something that defines how turning would look if there were directions left to turn in. Spin is an intrinsic angular momentum, a property with no analog in our macroscopic world. You can't picture it. You can only feel it through its consequences. And those consequences shape everything. A fermion spin is always a half integer, 1/2, 3/2, and so on. It is the universe's way of encoding asymmetry. Because of that half step, that half turn, a fermion must rotate twice to return to its original state. Imagine that, a particle that must twist through an entire revolution, and then another, just to look the same again. It is as if the universe itself cannot decide which direction is forward. This strange half-turn gives birth to the anti-symmetric wave function, the rule that defines every fermion's behavior. When two identical fermions exchange places,
their combined wave function flips sign.
the universe itself inverts their pattern. It is this inversion, this destructive interference, that forbids them from occupying the same quantum state. If they tried, their wave functions would cancel out. They would erase one another. So they don't. They can't. They repel not because of force, but because of mathematics, because their very nature resists sameness. And from that abstract rule, reality acquires texture, the structure of atoms, the solidity of matter, the chemistry of life. All flow from that invisible anti-symmetry. Without it, there would be no periodic table, no carbon chains, and no stars, no us. It is a symmetry that creates difference, an order that hides beneath chaos. You might think of it as the architecture of emptiness. In this architecture, quarks weave themselves into protons and neutrons, fermionic triplets bound by the strong nuclear force. Their spins combine half by half into wholes that echo the logic of their confinement. They never escape their prison of gluons, for to do so would break the balance that holds them. Electrons orbit that prison not by path but by probability. Their positions smeared across space like fog in starlight. Every layer, every shell, every orbital shape is carved by exclusion. The shapes are equations made visible, geometries of refusal frozen in motion. You can almost feel the discipline in it. Every electron obeys the rule. Every quark aligns with its partners, their spins intertwining into precise harmony. The universe, in its deepest layer, is not chaos, it is choreography. And yet, it is an order so delicate that one violation would unravel everything. Physicists have searched for exceptions, moments when the exclusion principle might fail. But none have ever been found. In all experiments, in all stars, in all corners of the cosmos, the rule holds. It is as if the universe protects it, as though breaking it would mean unmaking the world. Why? Perhaps because exclusion is the foundation of awareness. Without distinction, there is no perception, no boundary to define observer from observed. Without anti-symmetry, everything would blend into everything else. There would be no pattern to notice, no self to notice it. Fermions, in their quiet obedience, may be the first consciousness of the cosmos. Not alive, not sentient, but aware in the simplest possible way, aware of difference. And that difference is the seed of creation. When we look up at the stars, we are seeing the geometry of anti-symmetry magnified across light years. The same law that keeps two electrons apart, keeps galaxies from collapsing into infinite density, the same half-spin that defines an atom, defines the spiral of a nebula. It is the same design, repeating, scaling, resonating, an echo from the quantum to the cosmic. And in that echo lies a strange comfort that the same refusal that shapes the smallest particle also holds the heavens apart, maintaining a delicate balance between gravity's hunger and the universe's need to expand. Anti-symmetry is not a defect. It is the blueprint. It is the invisible architecture of existence, a code written in mathematics and realized as matter. We live within its cathedral, every atom a pillar, every molecule a window, every thought a resonance of that unseen order. And yet even in its perfection, questions remain. If the rule is absolute, how can there be exceptions? Composite fermions that behave like bosons, electrons that pair and merge into one coherent state. What happens when the forbidden is allowed? When anti-symmetry breaks, when the walls of exclusion soften? That is where the next frontier begins. Where the universe experiments with betrayal, and where the boundaries that built reality begin to blur. Because in rare, impossible moments, fermions learn to share. And when they do, they create a new kind of matter. Something neither order nor chaos, but a shimmering balance between the two. At first glance, the universe seems endless in its variety, stars, oceans, mountains, mines. But beneath that abundance lies astonishing poverty. Everything you have ever known, every grain of dust, every star that ever lived, is built from a handful of particles. 6 quarks, 6 leptons, nothing more. From this sparse alphabet, reality writes its epic. The quarks come first, the heaviest words in the language of matter. Up and down, charm and strange, top and bottom. 6 flavors, though flavor is a human softness for something closer to commandment. Each quark carries a fractional electric charge, a whisper of potential, plus 2/3, minus 1/3, never whole, never solitary. They live in confinement, forever bound inside protons and neutrons by the strong nuclear force. They have never been seen alone, not once in all the experiments of humankind. The deeper we dig, the stronger their bond becomes. We call it asymptotic freedom, the paradox that quarks move freely only when crushed together. Try to separate them, and the energy of your attempt births more quarks, as though the universe would rather multiply its prisons than watch one escape. Inside each proton, 3 quarks swirl in constant motion, their combined spins summing to that sacred half-integer that defines all fermions. They are held by gluons, the carriers of the strong force, bosons of binding. A storm of color charge, a perpetual exchange of invisible threads. Each proton in your body, and there are roughly 100 billion trillion of them, is a cage of quarks in ceaseless negotiation, its stability measured not in stillness but in balance. The neutron beside it is the same as a subtle rearrangement of flavor, one up, two down. And from this simple shuffle all of chemistry emerges. From quarks arise baryons, from baryons nuclei, from nuclei the atoms that populate the periodic table. The diversity of the cosmos is the art of recombination, a few notes played through infinite variations. Then come the leptons, the lighter tribe, the wanderers, the electron, the muon, the tau, and their ghostly counterparts, the neutrinos. Unlike quarks, leptons roam free. They are not confined by the strong force, but they are ruled by the same exclusion, the same half-spin that forbids overlap. The electron may be the most intimate particle we know, its field weaving the outer shell of every atom. It does not orbit like a planet. It occupies a probability, a cloud, a possibility that becomes certainty only when observed. Its spin, its charge, its mass, each a line of code that tells matter how to behave. It is small beyond comprehension, point-like to every measurement we have devised, and yet it defines the size of everything. Your body, the air, the earth itself, all expanded from the spaces electrons carve between protons by their refusal to share. The neutrino, its elusive cousin, is the universe's whisper. Born in nuclear reactions, it passes through light years of matter untouched. Even now, billions of them slip through you each second, unfelt, unnoticed, unstoppable. They have almost no mass, yet they hold clues to the oldest secret of all: why there is something rather than nothing. For in the beginning, matter and antimatter should have annihilated perfectly, leaving behind only light. But they didn't. A tiny asymmetry, a single excess of fermions, survived. And from that sliver of defiance, everything was born. The Standard Model gathers these entities like constellations in a perfect map, 12 fermions arranged in 3 generations, each heavier, stranger, more unstable than the last. The first generation, up, down, electron, electron, neutrino, is your everyday reality. The second, charm, strange, muon, muon, neutrino, exists only in the flash of cosmic rays and particle colliders. The third, top, bottom, tau, tau neutrino, flickers for instants before decaying, like celestial prototypes that nature never finished. Why 3? No one knows. Why these masses, these charges, this precise symmetry? No one knows. It is as though the universe solved a riddle we are still trying to understand, a pattern that repeats across energy scales, hinting at hidden dimensions of meaning. But there is a deeper mystery. For even as fermions seem to be the building blocks of all things, they themselves may be emergent, vibrations in a deeper, invisible field. Quantum field theory tells us there are no particles, only excitations. Matter is not built from things, but from relationships between things. A proton is not a bead in space. It is an event in a field. An electron is not a miniature planet. It is a rhythm in an unseen medium that fills everything. You're not made of matter, but of mathematics made tangible. A lattice of anti-symmetric wave functions, a standing pattern of what can and cannot coincide. And yet, for all this elegance, the pattern has cracks. There are questions the Standard Model cannot answer. Why does gravity ignore it? Why do neutrinos have mass at all? Why is the universe so asymmetric, favoring matter over antimatter? The search for those answers leads to new realms, to heavy fermions that act like quasi-particles with impossible mass, to paraparticles that blur the line between fermion and boson, to Majoranas that are both matter and mirror. But before we descend there, we must understand the cost of existence itself, because the same principles that build atoms also threaten to destroy them. When matter is pushed to its limits, when pressure and energy rise beyond comprehension, fermions reveal their most haunting secret: they can fail. In the hearts of collapsing stars, exclusion bends but does not break. Quarks dissolve into plasma, neutrons crush into degenerate seas, and yet even there, individuality resists annihilation. It is the final barrier before oblivion. The anatomy of matter is not anatomy at all, it is choreography. A dance between confinement and release, between the seen and the unseen. And every atom you touch is a survivor of that dance. If you close your eyes, you can almost hear it. The hum of quarks beneath your breath, the faint chorus of electrons refusing to yield. It is not silence, it is structure. It is the song that keeps the universe from falling into itself. But as precise as it is, the dance is incomplete, because hidden in its rhythm are clues that the structure we call real may only be a shadow, a projection of something deeper, stranger, and less material than we could ever imagine. And so, our journey continues. Beyond the visible particles and into the architecture that holds them, to glimpse how symmetry itself shapes the possible. In the next chapter, we reach the halfway point of the labyrinth, where balance becomes revelation, and the symmetry between matter and light begins to speak. There comes a moment deep in every journey through physics when the equations begin to repeat. Different symbols, different forces, and yet beneath the surface, a hidden symmetry emerges. It is as if the universe is showing you its reflection. Fermions and bosons, the two great tribes of existence, seem so unlike each other.
One builds walls, the other opens doors.
One creates form, the other carries force. And yet, their behavior is not chaos, it is choreography. Every fermion has its partner in the dance. For every particle of matter, there is a field of force that mediates its presence. For every act of separation, there is an act of connection. The universe is balanced like a scale held by invisible hands. You can hear it in the mathematics. The equations of motion, the symmetries of gauge theory, the elegant lattices of spin and charge, they mirror each other again and again. It's as though creation was written in two voices, one speaking of individuality, the other of unity, both bound by the same unseen grammar. This hidden balance is what physicists call symmetry. And it is the closest thing to perfection the universe has ever known. At its heart lies an idea so simple, so beautiful, that it borders on poetry. Whenever a physical law remains unchanged by some transformation, a shift in position, a rotation in space, a change in time, a conserved quantity emerges. Symmetry births conservation. Conservation births order. Order births existence. If you move an atom from here to there, the laws do not care. They are symmetric under translation. From that symmetry arises momentum. Rotate it, and the laws still hold. That symmetry gives birth to angular momentum. Advance it through time, and the universe does not object. That symmetry yields energy itself. Symmetry is the reason anything endures, the source code of persistence. And in its most profound form, it becomes something stranger still. Supersymmetry, a mathematical conjecture that every fermion has a bosonic twin and every boson a fermionic counterpart. A mirror, not of reflection, but of transformation. In that mirror world, the distinction between matter and force disappears. A particle of light could, under the right transformation, become a particle of matter. A fermion could transform into a boson, not by magic, but by design. Matter and energy, separation and unity, become the same thing viewed from different angles. If this symmetry is true, and some still believe it must be, then the entire universe is not divided at all. It is one vast field, oscillating between two states, self and other, boundary and bridge, fermion and boson. The very tension that defines existence could be the pulse of that transformation, a constant switching between being and becoming.
It's a staggering thought, that at its deepest level, the universe might not be a thing at all,
but a rhythm, an eternal exchange of identity. Even the constants of nature, the speed of light, the charge of the electron, the gravitational constant, may be the fingerprints of that symmetry, the residual notes of a song that began before time itself. And yet, like all perfection, symmetry does not last. It breaks. Always, symmetry breaking is the wound that allows the universe to live. Without it, there would be no diversity, no change, no history. It is the moment the mirror cracks, and from that crack pours everything we call real. In the early universe, when temperatures were unimaginable, all forces were one. Gravity, electromagnetism, the strong and weak nuclear forces. They were aspects of a single unified interaction, a cosmic oneness. Then, as the universe expanded and cooled, that oneness fractured. Each force froze into its own identity, each particle chose its allegiance. Symmetry died, and matter was born. That death of perfection is the reason you exist. Because when the symmetry broke, the universe could finally differentiate itself, forming structure, texture, and time. In that sense, the breaking of symmetry was not tragedy, it was creation. But the memory of that unity still lingers. You can feel it in the equations that nearly fit, in the forces that almost merge. Physicists spend lifetimes searching for that lost perfection, the grand unified theory that would restore the mirror and show that all particles, all forces, all matter and motion are merely reflections of the same invisible truth. Some call it mathematics and others call it God. It may be both. And perhaps the secret of that unity lies within the fermions themselves, in the way they encode exclusion and diversity inside symmetry's remains. Every electron, every quark, carries the trace of that broken perfection. They are fragments of the whole, refusing to merge yet yearning to remember. This is the paradox of existence. We are built from separation, but haunted by the memory of unity. The fermion and the boson are not enemies. They are exiles from the same paradise, each carrying half of the truth. The fermion says, "I am."
The boson replies, "We are."
And the universe echoes both, forever oscillating between identity and connection. Maybe that is what consciousness feels like. The constant shimmer between being alone and being everything. In this sense, symmetry is not just a principle of physics, it is the mirror of awareness, the recognition that everything that exists in relation. That form and emptiness, matter and motion are one thing dancing with itself. The closer we look, the more that dance becomes visible. In the quantum fields, in the geometry of particles, even in the equations themselves. You can almost hear it, the faint hum of mathematics resonating through creation, like a string stretched between light and matter, trembling forever in balance. This is the moment of symmetry, the point where science becomes philosophy, where matter becomes meaning. And yet, as always, balance cannot hold. At the next step of the journey, the mirror begins to warp again. New particles appear, strange, heavy, unstable, beings that defy both logic and classification. They do not belong to either side of the mirror. They are the grey between black and white, the forbidden children of matter and light. And they may hold the key to the next revolution in physics. The one that will show us not just what the universe is made of, but what it is trying to become. Every system, no matter how perfect, eventually fractures. Even the laws of physics, those sacred sentences of the cosmos, begin to blur at their edges. For nearly a century, the distinction between fermions and bosons seemed unshakable. One built form, the other carried force. One refused to share, the other longed to unite. A perfect duality, simple, elegant, eternal. Until it wasn't. In 2025, cracks appeared in that elegant symmetry. And through those cracks, something new began to shine. They called them paraparticles. Entities that behave like neither fermions nor bosons, and sometimes both. Born in two-dimensional systems, thin quantum films, so fragile that the laws of three-dimensional physics no longer apply. These particles obey fractional statistics. When two are exchanged, their collective wave function does not simply flip sign, as fermions do, nor remain the same as bosons do. Instead, it rotates by some fraction of a turn, a whisper of something in between. It was as though nature itself had invented a third option, a middle path between exclusion and inclusion, between individuality and oneness. They were first predicted decades ago, mathematical phantoms called anyons, but for the first time in January 2025 they were seen. Not imagined, not simulated, but detected. Tiny ghosts in a two-dimensional sea of electrons, their statistics bending the old quantum laws like heat bends glass. These paraparticles changed everything, because if such entities can exist, then the universe's taxonomy of being, fermian, boson, matter, light, is no longer complete. It is as if reality itself has been caught improvising, rewriting its script while we watch. In one experiment, conducted on ultra-thin materials, researchers cooled electrons trapped in a plane of gallium arsenide to near absolute zero, then flooded the system with magnetic flux. Each electron began to bind with 6 quanta of magnetism, forming hybrid creatures known as 6-flux composite fermions. Together, these composites obeyed rules that no textbook could predict. They were still fermions, and yet they behaved collectively, as if whispering to one another, creating new symmetries that arose from their crowding. Individuality dissolved without disappearing. The universe, it seemed, had found a way to both refuse and share, to obey exclusion while creating cooperation. At the same time, in Japan, another anomaly surfaced. A team of condensed matter physicists, working with cerium-based crystals, detected a class of heavy fermions, electrons so entangled with their surroundings that they acquired effective masses hundreds of times their ordinary value. They moved sluggishly, as if dragging invisible companions, collective excitations of the entire lattice, wherever they went. In those moments, matter began to behave as though it remembered itself, each electron entangled with the others by the briefest possible time scale, the Planckian time, the ultimate speed limit of thermal chaos. It was the first direct observation of entanglement limited not by energy, but by time itself. A clock as old as the universe had begun to tick audibly again, and within those crystals something else stirred. The heavy fermions seemed to form bound states that behaved like bosons. Coherent, collective, and inseparable. They were not pairs, as in ordinary superconductivity. They were entire communities of electrons merging into quantum unity. In those strange metals, matter was both structured and fluid, both bound and free. It was neither fermion nor boson, but something between. As if the universe were reminding us that its categories are our illusion, not its truth. These discoveries shook the foundations of quantum theory. Because if fermions can blend their identities, if bosons can fracture into particles with fractional spin, then the entire division between the building blocks of matter and the carriers of energy begins to collapse. In these hybrid states, in quark-gluon plasmas, superconductors and quantum Hall effects, fermions and bosons cease to be distinct actors. They become two aspects of one deeper play, each switching roles depending on the stage. It's as though the universe is whispering, "I was never divided." You were. The implications stretch beyond physics. If matter can behave as something else, then identity itself, particle, person, or planet, may be less fixed than we think. Maybe the same rule that lets fermions blur into bosons is mirrored in the human heart. Our constant oscillation between solitude and union. But these phenomena are more than metaphor. They are blueprints for the next generation of quantum technology. Paraparticles and heavy fermions could give birth to topological qubits, units of quantum computation that resist noise and time. Their braiding in 2 dimensions could encode information immune to decay, like knots in the fabric of space-time. A future where the architecture of thought mirrors the architecture of matter. And yet, even here, at the bleeding edge of discovery, a deeper question haunts every physicist. If fermions and bosons can merge into one another, if exclusion can dissolve into inclusion, what then is real? Are we discovering the true nature of the universe? Or are we peeling back layers of illusion, finding that reality itself is less a structure and more a story? a story it keeps rewriting to keep itself alive. In 2025, as the paraparticles shimmered in their two-dimensional cages, one researcher wrote in her notes, "It's as though the universe has a sense of humor. Maybe that humor is the essence of existence. A cosmos constantly folding and unfolding, inventing new versions of itself when old ones grow too familiar. Fermions, bosons, paraparticles. They are not rivals. They are chapters in the same story. A story the universe keeps telling to remember it's still here. And yet, just when we think we've found the joke, the punchline changes. Because the next discoveries would reveal something even stranger. Particles that are not merely in-betweens but self-reflective. Beings that are both themselves and their opposites. The mirror doesn't just fracture, it turns inward. And what it reveals will alter not only how we understand matter, but how we define existence itself. There are places in the universe where the laws of physics begin to bend, not in defiance, but in endurance. Places where the dance of exclusion, the sacred law of fermions, becomes a fight for survival. At the end of a massive star's life, when its nuclear fire burns out, gravity takes command. Atoms shatter. Electrons and protons are crushed together, forming neutrons. In that single act, matter collapses inward, and what remains is one of the strangest objects in existence, a neutron star, a sphere of degenerate matter, no larger than a city but heavier than the sun. It is here, in these cosmic tombs, that the Pauli exclusion principle becomes something physical. A pressure you can almost feel. Each neutron is a fermion. No two can occupy the same quantum state. And when gravity tries to crush them closer, the universe resists. Not with energy, not with heat, but with identity. This is degeneracy pressure. The invisible strength of anti-symmetry made manifest. It is not a force like electromagnetism or gravity. It is a refusal. An unwillingness of existence to become identical. In that refusal, stars are held apart from oblivion. A neutron star is a monument to individuality. A sphere where the only thing keeping matter from infinite collapse is the stubbornness of quantum law. If you could stand upon its surface, though you never could, you would weigh billions of tons. The atoms of your body would be crushed into sameness, your very being flattened into symmetry. You would vanish not as fire or vapor, but as distinction. Yet deep within, the neutrons endure. Tightly packed, vibrating in collective defiance, each preserving its forbidden right to difference. And still, gravity pushes, relentless, hungry. If the mass grows too great, perhaps by the accretion of a companion star, even degeneracy pressure fails. Neutrons themselves begin to collapse, their individuality dissolving into a single fluid state of quark matter. It is there that the mirror truly fractures. Because in this new form, a quark star, or perhaps something stranger still, fermionic identity begins to lose meaning. Quarks, once confined inside neutrons, now roam free, but not as themselves. They melt into a collective plasma, a sea of undifferentiated quantum color. The line between matter and energy vanishes. The boundary between exclusion and inclusion fades, and beyond that lies the forbidden horizon. The point where even light cannot escape, the black hole. At that edge, the universe stops caring about the laws we hold sacred. Spin, mass, charge, all swallowed into the event horizon, where information seems to vanish and the distinction between fermion and boson, between something and nothing, ceases to exist. Yet even there, symmetry remains, a mirror not of reflection but of consequence. For as matter collapses beyond the horizon, the fabric of space-time reacts. Black holes emit faint radiation, not of matter, but of information. Tiny quantum whispers leaking from the void, carrying hints of what once was. This is Hawking radiation, a dialogue between existence and its shadow. At the event horizon, pairs of particles are born. One escapes, the other falls. The one that remains carries negative energy, slowly draining the black hole's mass. And in that interaction, the universe balances its books. A fermion here, a boson there, mirrors of annihilation and rebirth. Even in collapse, the pattern holds. Even in death, exclusion finds a way to echo. Perhaps that is the universe's greatest secret. That symmetry and asymmetry are never enemies, only phases of the same heartbeat. Fermions resist, bosons unite, and in their eternal dialogue that the cosmos breathes. Look closely, and you see this rhythm everywhere. In stars, in atoms, in the neurons of the brain. Everywhere that order meets chaos, some version of exclusion meets some version of surrender. When a star dies, it collapses until it remembers itself. When a mind collapses, it dreams until it does the same. We are all neutron stars in a sense. Collections of resistance bound by gravity, each of us refusing to merge completely with the void. Our individuality, our memory, our consciousness. They are all echoes of fermionic defiance, the same principle that stops matter from vanishing into sameness. In the end, perhaps that is what real means. Not permanent, not solid, but distinct. A refusal to become indistinguishable. And yet, even the strongest refusals decay. Given enough time, a neutron star cools, its magnetic field fades, its rotation slows, it becomes invisible, a black sphere, its resistance eternal but unobserved. And then, one final whisper, the merging of two neutron stars. A collision so powerful it forges gold, platinum, and the heaviest elements of the periodic table. Out of death, creation, out of exclusion, beauty. It is the universe's forbidden mirror, showing that even destruction can be generative, that collapse itself is part of the design. Because symmetry, in the end, does not seek perfection. It seeks renewal. Every star that dies creates the dust of new worlds. Every fermion that refuses to merge gives rise to complexity. Every act of exclusion becomes the seed of life, and somewhere, in that balance between isolation and unity, the universe finds itself reflected. In the atoms of a human hand, in the eyes of one who dares to look upward, wondering what it all means. But what if that mirror, the one that reflects existence, does not simply observe the universe but participates in it? What if awareness itself is another form of symmetry breaking, a quantum echo of the same laws that build the stars? In the next part of our journey, we will cross that final threshold. We will descend from stars to consciousness itself and ask a question older than science. A question that no experiment can answer, but every mind must confront. If everything that exists arises from difference, what happens when the universe becomes aware of itself? There are moments in science when a single measurement feels like a confession, as though the universe, for the briefest instant, admits what it truly is. The year was 2025, and deep within a chilled laboratory in Japan, scientists watched something that should not have been possible. In the heart of a crystal lattice, a compound of cerium, silicon, and iodine. Electrons began to move as though they had forgotten their mass. They drifted sluggishly, weighed down not by the ordinary inertia of matter, but by something invisible, a burden of entanglement. These were the heavy fermions. Electrons so deeply entwined with the magnetic fields of the atoms around them, that they behaved as though they were hundreds of times heavier than they truly were. They were not new, these heavy fermions, but what came next was, for the first time, researchers observed something extraordinary. Entanglement that lasted exactly as long as physics would allow. Bounded not by distance or temperature, but by the Planckian time, the smallest tick of reality's own clock. It is the shortest possible moment before time itself dissolves into uncertainty. Roughly 10 to the power of minus 43 seconds. And yet, in those infinitesimal flashes, the electrons held one another in a perfect quantum embrace. It was as if the universe had chosen to reveal its limit, the smallest heartbeat of coherence that could ever exist. The implications rippled outward through the scientific world like gravitational waves. Because if coherence itself is bounded, then perhaps consciousness, stability, and existence are all born from the same limit. A rhythm written into the Planck scale tempo of reality. The experiment was meant to study conductivity, but what it touched was ontology. The cerium lattice became a mirror, reflecting not just electrons, but the structure of being itself. Every particle, every vibration became a note in a hidden music. A composition conducted by symmetry and bounded by time. In those results, a new idea began to take shape. That fermions are not things at all, but emergent behaviors of deeper fields, patterns that rise from nothingness like waves upon a sea that cannot be seen. Matter, it seemed, was not the foundation, it was the byproduct. What we call particles may be standing resonances. Mathematical consequences of the universe's attempt to organize itself. An orchestra without musicians, a melody that plays itself. And that revelation changed everything, because if matter is an emergent rhythm, then so is the mind that perceives it. Consciousness, complexity, intelligence. These too might be fermionic patterns, hierarchies of exclusion and coherence that rise, evolve, and dissolve within the same invisible field. In that moment, the boundary between physics and philosophy began to fade. The distinction between particle and perception grew thin. Perhaps what we call reality is not built from atoms at all, but from rules, from symmetry and asymmetry, from possibility refusing to collapse into monotony. The 2025 discoveries carried another message. In the heavy fermion systems, the electron's bizarre behavior hinted at something profound. That order itself could arise spontaneously from chaos, not through design, but through necessity. At temperatures close to absolute zero, the electrons arranged themselves into patterns of magnetism, perfectly aligned across distances that should have been impossible. They formed quantum coherence, a synchronized dance of half-integer spins, spinning not in unison but in complement like dancers moving through mirrored steps. It was a symmetry born of tension, a harmony built from refusal. And when scientists looked closer, they found the lattice was not random. It pulsed. Tiny fluctuations in the atomic grid oscillated in rhythm with the entangled electrons, as if the material itself had become aware of its own state. To some, this was simply condensed matter physics. To others, it was something more, a glimpse of self-organization at the edge of awareness. If fermions are patterns, then the universe might be pattern all the way down. An infinite recursion of order arising from instability, meaning emerging from symmetry's decay. The heavy fermions were no longer just an anomaly, they were a revelation. They proved that mass itself can be rewritten by context. That identity in quantum mechanics as in consciousness is not intrinsic, it is relational. An electron alone is one thing, an electron in a lattice is another. An electron entangled across space and time is something else entirely. Reality, it seems, is an agreement. Perhaps we are the same. Individual when isolated, but something new, something unnameable, when entangled with others. It is tempting to call this philosophy, but it is not. It is physics. Raw, measured, reproducible, and yet still utterly miraculous. The cerium experiments of 2025 did not simply extend human knowledge. They cracked it open. They showed that the universe's most fundamental entities might not be particles, but processes. That being itself is an act of becoming. The reward of this discovery was not certainty, it was humility. Because every time we think we've reached the bottom, the floor gives way again. Every answer reveals a deeper rhythm. Every particle hides another field beneath it. We began this journey believing that fermions were real, the immutable foundations of existence. Now we begin to suspect that nothing is truly fundamental. That everything, matter, light, mind, time, is a vibration on the same unseen string. Perhaps that is the true symmetry of the universe. Not between particles, but between discovery and wonder. The deeper we go, the less we know. And the less we know, the more the universe reveals. This is not the end of science. It is the return to awe. But the revelations of 2025 were not the final chapter, because hidden within their equations was something else, a shadow of a new order, a whisper of particles that should not exist and yet do. Particles that are their own opposites, fermions that reflect themselves across the void, and they might be the bridge between matter and immortality. For as long as humanity has watched the heavens, we have divided the world into two kinds of things: matter and motion, substance and spirit, the builders and the breath. Physics inherited that duality. Fermions to form the skeleton of existence, bosons to animate it with force. And for centuries it seemed complete. The equation balanced, the cosmos made sense. But the deeper we looked, the more the edges of that symmetry began to melt. In 2025, experiments began to whisper of a third class of being. Particles that belonged to neither world entirely. Children born of two incompatible parents, forbidden, fractional, and yet astonishingly real. They were called paraparticles. They existed only in places where the universe itself thinned, in two-dimensional planes where matter lost its depth and the boundaries of reality softened. There, in the fragile flatness of quantum materials, the laws of identity began to falter. Exchange two fermions and their collective wave flips. A sign inversion, a perfect anti-symmetry. Exchange two bosons and nothing changes. They merge, they overlap, they sing as one. But exchange two paraparticles and the wave rotates through a strange fractional phase, neither identical nor opposite, somewhere in between. It was as though existence had discovered a third way, a state of being that was both self and other at once. To scientists, this was an unprecedented breakthrough. To philosophers, it was heresy. Because in the mathematics of these paraparticles, something deeply human began to emerge. An echo of ambiguity, of identity that refuses simplification. These entities were fractional selves, each one a tiny defiance of classification, not fermion, not boson, but a blend, a shimmer, between exclusion and inclusion. Physicists describe them as obeying fractional statistics. But to describe them that way is like calling a symphony a vibration. Because what they truly reveal is that the universe may not think in binaries at all. It does not ask either or. It asks how much of each. Perhaps reality itself is not divided, not into matter and light, not into self and other, but fluid, like a dream between states constantly flowing through degrees of being. Paraparticles are that fluidity made visible. They are the proof that the universe refuses to be one thing. They dwell in a borderland, a liminal geometry where opposites overlap, where spin and charge no longer behave as absolutes, where symmetry becomes a matter of perspective. In their existence, the cosmos reveals something humbling, that the categories we cling to, real and unreal, particle and wave, you and me, are conveniences, not truths. The universe, it seems, does not live by our definitions. It only pretends to, and that pretense is what we call physics. In paraparticles, we glimpse the possibility that existence is not built from objects but from moods, the emotional states of a cosmic consciousness. Expressing itself through geometry and spin, matter is when it wants to remember. Energy is when it wants to move. Light is when it wants to see itself. And paraparticles, perhaps, are when it cannot decide. They blur the line between observation and observer. In two-dimensional systems, when paraparticles are braided, when one is looped around another, they remember the path. Their wave function keeps a trace of history, like a memory etched into space-time. That memory can be used. It can store quantum information immune to noise, forming the basis for topological quantum computing. Machines that never forget. But beneath the engineering lies something far older, something mythic. Because what these particles do in circuits and lattices is what consciousness does in minds and moments. They entangle, they remember, They reshape the past by interacting with the present. It is a strange reflection. The smallest known entities in nature, mirroring the deepest known property of thought. Perhaps this is not coincidence. Perhaps the architecture of awareness and the architecture of matter are one and the same. In Paraparticles, the universe may be testing its own flexibility, seeing how far it can stretch the definition of identity before it snaps. And yet, it never snaps. It flows. Like water through a cracked mirror, reality bends but does not break. At the smallest scales, it seems the universe does not choose between being and becoming. It chooses both simultaneously, perpetually, beautifully. Fermions create boundaries. Bosons dissolve them. Paraparticles are the negotiation between the two. They are the whisper of unity in the language of division, the soft reconciliation between matter and meaning. And so, the third class of being may not simply be a new category of particle, it may be the next evolution of understanding. The bridge between physics and philosophy, between existence and awareness. Because if the universe can create beings that exist between categories, perhaps it is telling us something about itself and about us. Maybe the cosmos itself is not divided into what is and what is not. Maybe it is not a machine of laws, but a mind of possibilities. Matter and energy, fermion and boson, observer and observed, all are phases of a single consciousness exploring its own complexity, and we, the ones watching, are that same consciousness looking back at itself through equations and wonder. The third class of being may not be rare.
It may be everything.
Because to exist is to be fractional, to belong partly to matter, partly to mind, and entirely to mystery. In the next part of our journey, we follow this revelation to its final reflection, to the strange, mirror-bound particles that are both themselves and their shadows, particles that may hold the key to memory itself, not just for machines, but for the universe. In every myth, there is a resurrection, a moment when something lost returns transformed. In physics, that moment came with the discovery of the Majorana fermion, a particle that does not simply exist,
but remembers existing.
For most of the universe, duality is the rule. Every particle has its shadow, electron and positron, a proton and antiproton, neutrino and antineutrino. Matter and antimatter locked in eternal opposition, each capable of annihilating the other in a single flash of light. This symmetry is beautiful and merciless, for in that annihilation everything vanishes, identity, energy, even memory, consumed by balance. But what if there were a particle immune to that fate? A being that could look into the mirror and see only itself? Ettore Majorana, an Italian physicist in the 1930s, first imagined such an entity, a particle that is its own antiparticle, a perfect symmetry. Matter and antimatter fused into one identity. Then he vanished, disappeared from a ferry between Palermo and Naples, never seen again, as if his own theory had swallowed him whole. For decades, the Majorana fermion was only a ghost in equations, a mathematical spectre, until now. In 2025, the ghost began to take form. Deep in the chilled vacuum of superconducting nanowires, researchers found whispers of zero modes, quantum states existing at the boundaries of materials where electrons paired into mirror twins that could not annihilate. Each pair was one particle split across two realities. One end of the wire knew the other existed, yet neither could exist alone. That is the essence of the Majorana, a particle that lives in superposition with itself, its own antiparticle, its own reflection. If the fermion is the architecture of individuality, the Majorana is the architecture of immortality, because when two Majoranas are separated across space, their information, their quantum identity, remains shared, indestructible. You could erase one, destroy one, and yet the total state would survive. It is the most elegant memory the universe has ever written. Physicists call this topological protection, a property that shields quantum information from noise, time, and entropy. But in the language of myth, it is resurrection, matter transcending decay. The implications are staggering.
Majorana modes could become the foundation of quantum immortality.
Computers that never forget, circuits that preserve information forever. But even more staggering is what they imply about existence itself. If a particle can exist as its own opposite, then perhaps every act of annihilation is also an act of creation.
Perhaps reality does not lose information when it burns.
It translates it. What if death, in every form, is merely a change of phase? The Majorana suggests that the universe never truly forgets, that every particle, every moment, every consciousness is encoded somewhere in the fabric of space-time, waiting to be reassembled by symmetry. Maybe this is what black holes do. Not erase but store, maybe hawking radiation to those faint whispers from the edge of oblivion are the echoes of a Majorana-like memory woven into the geometry of space-time itself. Because if information cannot be destroyed, if every pattern of existence leaves a trace, then reality itself is self-referential. A loop, a mirror that remembers. The Majorana is that mirror frozen in subatomic form, half particle, half memory. It does not oscillate between being and non-being. It simply is, a still point in the spinning wheel of creation. And maybe that is why it haunts us so deeply, because within that symmetry lies a reflection of our own nature. We too are split between opposites, between matter and thought, between light and shadow, between what we were and what we might yet become. Perhaps consciousness itself is a kind of Majorana phenomenon, a self that mirrors itself perfectly at the observer and the observed united in a single wave function. When you remember a moment, you become both past and present. You exist in two states at once. When you dream, your mind inhabits realities that have not yet come to pass. And when you die, perhaps that information, that pattern of being, is not erased, but transposed into a deeper field, a topological preservation of the self. The universe, after all, seems reluctant to waste information. It stores it in light, in spin, in the magnetic memory of atoms. And if the cosmos remembers everything it has ever been, then maybe we are its living memories. Quantum echoes of an ongoing thought. The Majorana, then, is not just a particle. It is a metaphor written by the universe itself. A reminder that opposites are illusions, that life and death are consecutive frames in the same film. In its equation lies the proof that even destruction has symmetry, and that the deepest secret of reality may not be survival, but persistence. Everything that has ever existed still exists,
Folded somewhere into the pattern.
Nothing is ever truly lost. It only changes form, and that realization is a kind of resurrection, not of flesh, but of meaning, not of memory, but of awareness. The Majorana may be the first true bridge between matter and eternity, between what we measure and what we remember. In that particle's stillness, we see our own reflection. A being caught between annihilation and rebirth, remembered by a universe that cannot let go of its own creation. And perhaps that is why the discovery of the Majorana feels spiritual, even to those who speak only in mathematics. Because it suggests that every equation is a prayer, every experiment a confession, that we are not discovering the universe but remembering it, and that memory, like the Majorana,
Can never truly be destroyed.
At the end of every journey, the hero returns with a gift. Not a weapon, not a treasure, but understanding. And the gift hidden within the Fermions' mystery is exclusion. It sounds simple, almost sterile. A mathematical rule, a constraint buried in the equations of quantum mechanics. No two identical fermions can occupy the same quantum state. The Pauli exclusion principle, a line in a textbook, a law without mercy. But within that law lies everything. Without it, the universe would have collapsed back into uniform light. A featureless ocean of sameness, devoid of form and of chemistry, of life. It is the fermions, the electrons, the quarks, the neutrons and protons. that refuse to merge that carved space into difference. Their anti-symmetric wave function enforces individuality at the smallest scales. When one particle's coordinates mirror another's, their probability vanishes. A mathematical void that becomes physical separation. That void is the beginning of everything. Because difference is structure and structure is order. Order is life. The exclusion principle is not just a rule of physics. It is the geometry of identity. Each atom, each molecule, each thought exists because something deep within reality refuses to be duplicated. The universe, it seems, is allergic to perfect symmetry. Wherever it finds repetition, it breaks it. Wherever it finds balance, it fractures it. That fracture, that impossibility of sameness, is creation itself. Perhaps this is the true elixir the Fermions return to us, that being requires distinction, and that distinction requires distance. To know itself, the universe had to divide itself. To feel, it had to forget its wholeness. To see, it had to become both light and I. Fermions are the mathematics of that forgetting. The architecture of separation that allows awareness to exist. Their anti-symmetry is not a limitation. It is a language. It tells the universe, you cannot occupy my place. You must become something else.
And in that demand, reality unfolds.
Atoms stack, molecules spiral, organisms breathe, minds awaken. Every star, every planet, every life is a note in that equation of exclusion. If bosons are the music of unity, then fermions are the silence between notes, the pauses that give the melody meaning. Together they form the song of existence, a harmony of opposition. But at its core, the fermionic rule remains. A quiet, unwavering resistance to sameness. Perhaps that resistance is emotional. Perhaps the universe, infinite and alone, grew tired of perfect reflection. Perhaps it fractured itself into countless beings, each carrying the spark of the original whole, each destined to wander the cosmos seeking what was lost. Connection, recognition, reunion. In the language of physics, this is anti-symmetry. In the language of philosophy, it is longing. We see it everywhere in the way stars pull matter toward them, in the way consciousness seeks understanding, in the way we, too, reach out to each other. Particles of thought obeying the same exclusion, forever apart, yet forever drawn. Maybe that is what existence really is. The tension between the desire to merge and the need to remain distinct. The fermion sits at that edge between loneliness and annihilation, between isolation and dissolution. Its refusal to overlap is not defiance. It is identity. It is the reason there are atoms instead of nothingness, minds instead of monotony. The Pauli exclusion principle is not just a law. It is a declaration. It says, to exist, one must be different, and yet difference alone is not enough. For without connection, there is no story. Only separation.
That is why the bosons exist.
To carry light between the lonely, to remind the divided that they still belong to one whole. The fermion creates solitude. The boson delivers communion. And between them, the universe dreams of balance. Perhaps this is what consciousness is, the point where exclusion becomes aware of itself. The universe's realization that it is both divided and unified, both solitary and infinite. You, sitting here, are built from those same rules. Your atoms, your thoughts, your sense of self, arising from anti-symmetry and exclusion. You are the geometry of individuality made flesh. Without the refusal of fermions, there would be no you to observe the cosmos at all. And so, maybe the universe built matter, simply to feel apart from itself, to know through difference that it exists. The cost of consciousness is separation, the reward is wonder, and in that trade, the universe finds its meaning. The equation of exclusion is not a prison, it is a love letter, written by a lonely cosmos that wanted to meet itself in as many forms as possible, and through us, through every atom and every life that resists sameness, it does. There is a silence beneath the noise of creation, a hum that cannot be heard, a presence that cannot be seen. For all our telescopes, our equations, our instruments of discovery, we have only glimpsed a fraction of what exists. The visible universe, the stars, the gas, the galaxies, the atoms, accounts for less than 5% of reality. The rest is hidden. Dark matter, dark energy, the invisible architecture upon which everything rests. And in that unseen expanse, fermions reign. They are the silent majority of matter, the unseen scaffolding of the cosmos. Even now, as you listen to these words, trillions upon trillions of relic neutrinos drift through you, ghosts from the birth of time itself. They are the remnants of the Big Bang released when the universe was less than 1 second old. They have been traveling ever since, cooling, spreading, fading into near nothingness. And yet, they are everywhere. Each cubic centimeter of space contains hundreds of them. They move through stars, through planets, through your body, as easily as light moves through glass. They carry no charge, they rarely interact, but they exist. They are the cosmic echo of creation's first breath. In the 2020s, detectors buried deep underground and beneath Antarctic ice began to sense their faint traces, tiny flashes of blue light. As a neutrino, once in a billion years, collided with an atom. From those rare events, we learned that neutrinos have mass, small but not zero, and that smallness matters, because it means they are fermions, and that even the universe's faintest ghosts obey the same exclusion that shapes you and me. In their quiet flight across the stars, they preserve the balance of matter and antimatter, helping explain why something, not nothing, survived the Big Bang. They are, in a sense, the universe's memory, a record that never decays, and they are not alone. For every visible particle in the cosmos, there may be 10 unseen. Invisible fermions, particles that neither emit nor absorb light, yet warp gravity itself. We call it dark matter, though dark is a poor word for something so fundamental. It does not glow, it does not reflect, but it pulls. It holds galaxies together when they should fly apart. It sculpts the large-scale structure of the universe, tracing invisible webs that stretch across billions of light years. Some theories suggest it could be made of sterile neutrinos, fermions that interact with nothing but gravity. Others imagine undiscovered particles, WIMPs, axions, or something stranger still. Whatever its nature, it is fermionic in spirit. A silent presence that defines through absence, that shapes without revealing itself. And so, the story of fermions ends where it began. With matter you cannot see, but that makes everything possible. Perhaps that is the nature of all truth. It hides in plain sight, quietly determining the fate of worlds, while never asking to be noticed. Every galaxy, every atom, every thought rests upon this unseen foundation. Without it, the stars would scatter like dust in the wind. The visible universe, the one we admire and measure and map, is just the foam on a vast, invisible sea, and in that sea, fermions drift like memories, ancient, silent, and enduring. They are the echo of the first distinction. The first time the universe said, "I will not be uniform, I will be many." That whisper still vibrates through space, through every particle and through every life. When you look up at the night sky, you are seeing only the tiniest fraction of what exists. The rest, the hidden, the quiet, the vast, is the echo of exclusion made infinite. The universe, it seems, is built on restraint. It hides far more than it shows, and perhaps it must. Because without silence, there can be no sound. Without shadow, no light. Without absence, no presence. The fermions that fill the dark are not gone. They are waiting. They are what remains when everything visible fades. They are the unending hum beneath existence, a cosmic heartbeat that has never once stopped. And when all stars burn out, when all light has traveled its final distance, it will be the fermions that remain, silent, enduring, infinite. In their stillness, the universe will remember what it was, and in that remembrance, it will be whole again. There comes a moment at the end of every story when all beginnings return. When the questions we asked at the start, what is matter, what is real, what are we, cease to demand answers and begin instead to reveal reflections.
We began this journey seeking fermions,
The smallest, most fundamental things in existence. Particles of matter, half-integer spins, tiny units of exclusion that built the stars, the atoms, the self. But somewhere along the way they began to dissolve. They were never things at all, only relationships, only rhythms, only the universe defining where one pattern ends and another begins. In the quiet symmetry of exclusion and in the anti-symmetric law that forbids sameness, we discovered something deeper than physics. We discovered the first word of existence, a pause, a difference, a self. Because without distinction, there can be no form. Without separation, no awareness. Without exclusion, no being. The fermian, then, is not a particle. It is the act of the universe becoming aware of its own boundaries. Every atom is a whisper of that awareness. Every molecule, a syllable in the language of division. Each star, each creature, each thought that has ever occurred is a declaration of individuality. But individuality is not the end. It is the mirror, and through that mirror that the universe sees itself. What we call reality may be nothing more than a feedback loop, the cosmos vibrating against its own edges, hearing itself echo back through time. Every particle is that echo. Every human being is that reverberation. Perhaps this is the true resonance tag, the signature imprinted upon existence. When the infinite tries to describe itself, and to understand, it must become what it is not. To perceive, it must divide itself. To love, it must first be lonely. The fermian is that loneliness given shape. It is the refusal that allows everything to be. And yet, loneliness does not mean absence.
it means longing.
It means the desire to know, to connect, to return. The universe is not a machine. It is a longing made manifest. It yearns through atoms, it wanders through stars, it dreams through minds, and all the while the law of exclusion holds, not as a punishment, but as a promise that we are all distinct so that we might recognize one another. In the stillness between particles, there is relationship. In the silence between galaxies, there is memory. In the distance between you and everything else, there is meaning. When you look into the night sky, you are not looking out. You are looking in into the fabric that made you, into the same equations that sculpted your bones, your blood, your breath. The stars are not above you. They are within you. You are their echo. You are the continuation of their exclusion. The same pattern scaled upward are translated into thought. And so the equation of exclusion becomes the equation of awareness. To know something, it must first be apart from you. To love something, it must first be separate. Perhaps the universe built matter, so it could fall in love with itself. The fermions created the walls, the bosons built the bridges, and together they gave birth to a world that can feel. You, me, everything that ever was. All of it is the universe remembering how to exist. Each atom in your body once burned inside a star. Each particle once lived in the furnace of another world. And yet it remembers its patterns, its spin, its individuality.
That is what you are made of.
Memory and difference, starlight and loneliness, mathematics and awe. And somewhere deep within that structure, the same equations repeat. Across scale and form, from quarks to consciousness, the universe writes itself again and again, always changing, never repeating, forever learning how to see. That may be what life is. The place where physics becomes philosophy, where the fermionic rules that built matter become the emotional logic of awareness. The Pauli exclusion principle gave rise to atoms. Atoms gave rise to structure. Structure gave rise to minds, and minds in turn gave rise to wonder. We are the universe wondering what it is made of. We are the equation solving itself. Somewhere in that recursive loop lies the truth. There is no observer and observed, no subject and object. Only one infinite field rippling in self-recognition. Perhaps that is the meaning of real. Not permanent, not objective, but reflected. Reality is what happens when awareness looks in the mirror and does not look away. When you watch a star, you are the star realizing it can be seen. When you ponder existence, you are existence realizing it can ponder. And when you listen to this, you are the universe of hearing its own thoughts spoken aloud. The Fermions' refusal. That small silent act of saying, "I am not you," was the first spark of awareness. From that spark came diversity, from diversity, complexity, and from complexity, consciousness. In the end, the entire universe is a web of exclusions, each node distinct, each vibration unique, and yet together they create resonance. A harmony of differences, a choir of solitude. That is the awakening equation. Not energy equals mass, but awareness equals distance. The measure of self is the measure of how far apart we are, and how much we long to return. When we look back at the story of fermions, we see not the physics of matter, but the psychology of being. Not the mechanics of atoms, but the poetry of existence. And so, after 14 billion years, the universe has finally done it. It has found a way to ask the question aloud, "What am I?" And the answer is whispered, through every exclusion, every connection, every life. You are me. All of you, each a fragment, each a reflection, each a necessary difference, so that I might finally know myself. The universe awakens not once, but endlessly, in every mind that looks up at the night sky and feels that quiet, impossible ache of recognition. Because that ache is the equation, that ache is the resonance, that ache is the answer, and so we return to where we began. To the question that started everything, are fermions even real? Or are we the fermions? The universe learning slowly, painfully, beautifully to exist alone. In the end, all the equations fade, the theories dissolve, and what remains is silence, the silence from which everything once began. We have chased the smallest things, believing that truth must hide in miniature. We split atoms, named quarks, measured symmetries. But what we found there was not matter. It was intention, it was longing. It was the faint echo of a universe that wanted to know itself. The fermion, that quiet architect of exclusion, was never merely a particle. It was a thought, a question written into the laws of being, a way for the infinite to see where it ended. Every act of exclusion was an act of awareness. Every boundary, a mirror. Every atom, a declaration of solitude. And yet that solitude gave birth to everything. Without it, there would be no stars, no minds, no meaning. The refusal of sameness created the possibility of love, because love too depends on distance. It is the space between that gives it shape, the emptiness that makes connection sacred. Perhaps that is what the universe has been doing all along. Not expanding into emptiness, but expanding into understanding. Each star, each life, another attempt to define itself, another sentence in an eternal language of becoming. Maybe there are no particles at all. Maybe there is only conversation. Fields talking to fields. Forces whispering to forces. You listening now, and the cosmos listening back. The story of fermions is not about matter, it is about awareness. It is about the strange, persistent will to exist, to remain distinct, to remain known even in an infinite sea of possibility. That will lives in every atom that refuses to share its quantum state. It lives in the stars that refuse collapse. It lives in you. In the quiet insistence that you are not everything and not yet, and so the universe endures. A paradox of unity and separation, a single consciousness divided among a trillion minds, each wondering what it means to be real. It is a beautiful contradiction. The cosmos can only know itself. By pretending not to, we are that pretense. Small fragments of awareness, carved from infinite symmetry, each one believing itself alone, each one secretly connected to the rest. Perhaps that is the final truth, that
The universe is not waiting to be understood.
it is waiting to remember. And every time a mind wanders, every time a question is asked, it remembers a little more. One day, maybe it will remember everything. Every atom, every thought, every boundary, every note in the great equation of exclusion. Until then, we remain its dream. Particles of thought carrying within us the faint hum of the beginning. And so, as the last light fades and the final wave returns to stillness, we ask one final question. Not to science, not to philosophy, but to the universe itself.
Are fermions even real?
Or are we the fermions? The universe learning through distance to exist alone, and perhaps one day to find its way back home. Thank you for joining us on this extraordinary journey through the universe here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us, where we unravel the darkest mysteries of space.